Hi, I am Çağdaş. I'm a second year physics student, and I will be presenting my Physics 211 project. In our project, we try to visualize the sound waves with laser setup and Chladni figures, and we try to prove some wave properties like superposition and some wave phenomena like beats. In our experimental setup, we used a glass bowl, a balloon to stretch the top of the bowl, a Bluetooth speaker which is placed inside the bowl to vibrate the membrane, a laser pointer to obtain the laser figures, a small mirror to reflect the laser, and some salt to observe Chladni figures. We vibrate the balloon with our speaker, and the laser beam, which is reflected from the top of the membrane, draws some figures related to the membrane's vibration. After that, we sprinkled some salt on the plate and tried to observe the Chladni figures of these vibrations. We observed Lissajous curves when we vibrated the balloon with a single frequency. For obtaining the Lissajous figures, there should be two perpendicular sinusoidal waves that determine the position of a point. In our case, one of the waves is the wave that we sent and the other wave is the balloon's natural vibration frequency. In this picture, we observed 1-to-1 frequency ratio Lissajous curve, which is circular. After that, we tried to get some model shape with same frequency that we applied to make sure we were vibrating the balloon with the resonant frequency to obtain 1-to-1 Lissajous curve with sprinkled the salt and vibrating the membrane. We tried the same experiment with two sound waves with the same laser setup to see if we were observing the expected figures using the superposition principle. These are the figures that we obtained and the expected figures which are obtained a Python code by summing the two sound waves according to the superposition principle. The frequencies of this figure are tritones, which one of the frequencies is square root multiplier of the other. The reason of the figure is spinning is since the ratio is irrational, there is no repeated pattern over time, so it seems spinning. We try to observe the beat by giving 1 Hz apart frequencies. We observe that our image shrinks and enlarges with 1 second period, which is expected from the 1 Hz beat frequency. At the end, our data matches with the theoretical predictions. It gives the expected figures in superposition and beats. However, our experimental setup could be improved. We could use a metal plate as membrane for solve the non-uniformity problem of balloon, because when you stretch the balloon there are some non-uniformities, but at the end we got satisfying results that matches our theory. Thank you for listening.